Hello, 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 everybody. Checking to make sure I'm not on mute again like science class last time. And I'm not. We're ready. Good morning. Hello. Happy Thursday. It was a heck of a day yesterday, and there's a lot of real life big picture things to talk about. We will continue to talk about them, fifth graders. But for now, let's not forget about it, but just put it to the side and continue our look at multiplying fractions by whole numbers. Okay, there's what you're going to need. There's the I cans down there. I can define multiplication as repeated addition of a given value, and I can multiply a fraction by a whole number. So let's jump right into it. And before we really get to today's work, and before we even get to linking addition to multiplication, I want to just do a refresher on the two parts to a fraction, okay? Because this is when we're understanding this link between repeated addition and multiplication, it's important to remember what the two parts of a fraction are, okay? And this idea that we have above our line, we have our numerator. I'm going to use n for numerator. And below, we have a d for denominator, okay? And our numerator on top, okay, when we're thinking about multiplying a fraction by a whole number, that is going to be the important bit and the bit that we're going to be working with most directly, because the numerator refers to the number, why I call the numerator, of, I'm going to say number of units, okay? With whole numbers, there's only one thing there, so we don't really think about it in terms of this terminology, in terms of the number of units, but whole numbers really are numerators, okay? If you have a number like 5, for instance, okay? 5 tells you, when we talk about the number 5, we're talking about really 5 things, or 5 units, right? 5 fingers, 1, 2, 3, 4, 5, okay? With a whole number, we don't have to think about it because the denominator, or the size / value of each unit is implied, okay? We don't have to write it, but with our 5, right, we have 5 fingers. The size of each unit is 1 finger, okay? So technically, the number 5, if you were to write it as a fraction, would be 5 over 1. Okay, 1 whole finger. And there are 5 of them. Okay, the units we're counting in are in fingers, and then 1, 2, 3, 4, 5 of them. Okay. As far as the denominator in fractions goes, all that's telling us is the size of the value of each piece, right? If we were thinking about this in, pizzas are popular when we're talking about fractions, right? This would be 5 whole pizzas. The unit that we're dealing with and that we're counting by is whole pizzas, and we're counting 1, 2, 3, 4, 5 of them, okay? If we had half pizzas, the unit that we're counting in, or how we're counting by, would be in halves, okay? 1/2 of a pizza, 2 halves, 3 halves, 4 halves, 5 halves, right? Kind of this, right? There's 5 halves. If I bend half of my fingers down, right? How much of my fingers are showing? 1/2, 2 halves, 3 halves, 4 halves, 5 halves, okay? When we're dealing with multiplication, because we're just doing repeated addition, or really counting by a certain size group, by a set size group, the numerator is going to be the important one, okay? The denominator, for the purposes of this lesson, is not going to change because we're not changing the size of our group. We're not doing anything to change, to alter the size of our group. All we're doing is we're adding the same size group over and over again. So our denominator for this is going to stay the same, okay? Let's look at it in another way. I got a little sequence for us here, okay? Over here, we've got 4 different multiplication equations, Okay, we have 3/4 times 1, or one group of 3/4. And as we know, that equals 3/4. Okay? 3/4 times 2, or two groups of 3/4, which equals what? Our size of our group hasn't changed. We're still in fourths, but we have 3 plus 3 is 6/4. Right? Next one down here, 3/4 times 3, or 3 groups of 3/4. 3 groups with 3/4 in each group. And we want to know how much total, right? 3/4 plus 3/4, we saw up here, is 6/4. Let's add 3 more fourths to get to 9/4. And so on. Are we starting to see, kind of over here in our little squiggle, are we starting to see a pattern emerge? What will come next in this pattern? 4 groups of 3/4, right? 4 groups with 3/4 in each group. So how much total? 3, 6, 9, 12. 12/4. And I'm noticing something here. I hope you're noticing that as well. Again, when it comes to our numerators, and as far as our numerators are concerned, take a look. 3 times 1, again, or one group of 3 things, each one of them the size of a fourth, equals 3. 1 times 3 is 3. 3 times 2, 6. 3 times 3, 9. 3 times 4, 12. What would come next? 3 times what? We've got 1, 2, 3, 4, 5, right? 3 times 5. And the size of the piece is still fourths, right? So the next term in our sequence or in our pattern would be 15/4. Okay? So when we're dealing with a whole number multiplied by a fraction, okay, the denominator from our fraction is going to remain the same. Okay, because essentially all we're doing is we're counting equal groups of that fraction. And when we add fractions, the denominator stays the same, and it's the numerator that gets added. So in this case, the denominator stays the same. It's the numerator that gets multiplied. Okay, that's really why for the past 2 years, really, because I had you in 4th grade, that's why for the past 2 years I've really been coming back to this idea of multiplication is repeated addition. Okay, it's just taking groups and adding it a given number of times. That's all multiplication is on a conceptual level. Let's try a few here on our digital whiteboard. There we are. Okay, so first one I want us to try is, whoop, hold on, I need the green pen, there we go. Let's try 2/3 times 6. So remember, just like adding fractions, okay, it's our numerator that's changing, and our denominator stays the same, because we're not changing the value of each piece. Okay, all we're doing is we're counting 2/3 6 times, and then going, okay, how many thirds do we have? Right? 2 times 6 is 12, and our denominator stays the same. So we end up with 12/3. 2 plus 2 plus 2 plus 2 plus 2 plus 2 equals 12. And all of those units are thirds. So we have 12/3. And for those astute cookies out there, thinking about 12 divided by 3, right? How many groups of 3/3 can we make to make some whole numbers? Yeah, we end up with 12 thirds equals 4. 3 thirds plus 3 thirds plus 3 thirds plus 3 thirds equals 4. Okay, again, pretty straightforward with this one. Okay, it'll get more complicated once we get into mixed numbers and once we get into multiplying a fraction by a fraction, but we're not there yet. So for now, just considering this idea of a fraction times a whole number is essentially repeated addition of that fraction. Okay, you can also think about it of, dividing up that whole number, but the most straightforward way to get into this is with repeated addition of that fraction. Let's try a few more. I'm going to give you like three practice problems straight away here. Let's do 4/9 times 5. Let's also do 7/10 times 3. And for our last one, why don't we do 6/7 times 4. Try those 3 out on your own. We had a question in the chat that I'll get to in just a second of why does 12 thirds why is 12 thirds equivalent to 4? Okay, great question. And let's work on that. I'm going to scoot these practice problems to the side and work on them on your own. But I think it's easiest to draw a picture for this. So let's go use our magenta pen here. And let's draw that out, okay? Let's draw some thirds here. So here's our ones bar. Whoop, there we go. And we're cutting it into thirds. Whoops. Get all the way over there. Oh, come on. I think I've got to go all the way. Nope. Really? That is curious how it's no longer letting me cut it into thirds. Oh, that didn't. Come on. See, now I'm doing the thing where I'm just struggling with technology to struggle with technology. Nope. Doesn't want to do the same thing as before. So you know what we're going to do? We're going to be vindictive and erase it. Let's get some more thirds in here that we can copy. Now how do we paste? I'm sure this is riveting, absolutely riveting television. Okay. Let's forget that. There we go. The blue pen will do it, but not the pink pen, which is very strange. So here we've drawn, pay no attention to the change in color, but here we've drawn 4 full fractions bars. Okay? So we've got 1, 2, 3, 4. 1, 2, 3, 4. And each one is divided up into thirds. So we have 1/3, 2/3, 3/3. Right? Let's keep counting our thirds. 4/3, 5/3, 6/3. All right, so we have 6 pieces, each one equals to 1/3. And so our 6/3 are equivalent, they have the same value as 2 wholes. Okay, it's like having two pizzas, cutting each pizza into 3 equal pieces. And how many pieces do you have? You have 6. And each piece has the value of a third. Same thing here, 7 thirds, 8 thirds, 9 thirds, 10 thirds, 12 thirds. Oh, 12 doesn't come after 10. I taught most of you in first grade, so you should have learned to count from me, and I should have learned to count from me. There we go. So we can see there 12 pieces, each one with the value of a third, has the same value as 4 wholes, because 3 thirds equals to each whole, if that makes sense. Okay, let's go back to our practice problems. Zoop. There we go. So we had 4/9 times 5. Remember, we're multiplying the numerator, keeping the denominator the same. 4 times 5, 5, 10, 15, 20, over 9. There's our improper fraction. 7 times 3, 21, over 10, 21 tenths. And then 6 times 4, 24, and the size of our piece stays the same. It's in sevenths. And then if you want to convert these to mixed numbers, thinking about how many groups of 9, how many groups of 9/9, or how many ones, can you make with 20? 9, 18, and we're not going to be able to go past there, so we have two wholes, and then 2/9 left over, because we took 9/9, 18/9 makes 2, with 2/9 left over. Next one here, how many tenths? Count by tens until you can't anymore. 10 tenths equals 1. 20 tenths equals 2. And that's it. We have 1/10 left over, right? If we've taken 20 of those 21 tenths, 21 minus 20, to make our 2 wholes, we've got 1 remaining for a mixed number of 2 and 1/10. Last one here, count by sevens to find your whole numbers. 7/7 equals 1. 14/7 is 2. 21/7 is 3. And 28/7 would be 4, but that's too many. So let's go back. We've got 3. And then we use 21/7 to make our 3 wholes. So 24 minus 21. 3/7 left over. Okay. Improper fractions are totally acceptable answers. They are accurate in terms of value. But mixed numbers, I think, are the most clear and the most straightforward if we can get to them. So remember, if you ever see that improper fraction where the numerator is larger than the denominator, that's your clue, or the numerator has a greater value than the denominator in terms of its digit, then that's your clue that you have something greater than 1. So you can make it a mixed number. Okay, if our numerator is smaller than the denominator, 7/8 or 9/10 or 1/5 or 2/1000, right? That tells you that your value is less than 1. All right, so remember, key to this, multiply your numerators. That's what we're doing here. We're doing repeated addition. We're doing 3, 4 times. And our denominator, the size of our piece, is staying the same when we multiply by a whole number. So multiply your numerators, keep your denominator the same, and you will do just fine. Thank you. Office hours start in about 10 minutes if you need it. Otherwise, exit ticket, then iReady Math if you're done early. And I will see all of you. You will see each other at PE at 12:30, and then I will see all of you at 1:15 back on Zoom for our intro to journalism. Good luck, happy math, and we will see you soon.